We're now going to look at Lesson 10.6, Video 3. This is the power series for e to the x. This power series comes from an application of the exponential power series formulas combined with the binomial expansion theorem, which we are not going to use today. I'm just going to say this is the formula. Let's see if we can learn how to use it. This formula allows us to calculate the powers of e using this formula. And the nice thing about this is this means that even though e is a transcendental number, we can actually calculate a value to it. Obviously, if we want to find e to the first power, we just use a 1 in place of x. And then we can calculate the value of e. We're going to look at calculating some other values of e. Let's first of all look at calculating the value of e squared. That would be the sum of 2 to the nth over n factorial, which would be 1 plus 2 plus 2 squared over 2 factorial is 1 times 2, which is 2, plus 2 cubed, which is 3 factorial is 1 times 2 times 3, which is 6, plus this would be 2 to the 4th power over 4 factorial, which is 24. And let's go one more, 2 to the 5th power, and this would be 120. So this would be 1 plus 2 plus 4 over 2 plus 2 cubed is 8 over 6. 2 to the 4th is 16 over 24. 2 to the 5th power is 32 over 120. So this is 1 plus 2 plus 2 plus 4 over 3, 1.333 plus 16 over 24, that's 2/3, plus 6, plus, and we'll leave the last one off. This gives us 1, 2, 3, 4, 5, 6, and these two make 7. So e squared, after 5 terms, or the 5th partial term, is equal to 7. Now you'll notice that we'll add values on, and so it'll end up being a little bit more than 7. The actual value of e to the 2nd power is 7.389. And so as we add up all the others, we'll get closer and closer to the correct value. Let's look at a couple of other more difficult to calculate. But with calculators, all of this is easy. And of course, on your calculator, you just have an e to the x button, which makes it even easier. But there's some value in knowing this because computers can only add and subtract. And that means they can do multiplication because that's repeated addition. They can do division because that's repeated subtraction. And so we have to have ways that we can calculate these numbers on a computer when they're not designed, when they're not capable of doing anything but adding and subtracting. Let's do e to the negative 3/4 power. This would be 1 plus negative 3/4 plus negative 3/4 squared over 4, or over 2, sorry, 2 factorial, plus negative 3/4 cubed over 6, plus negative 3/4 to the 4th over 24. We're only going to go up to the 4th iteration. This will simplify to 1 minus 3/4 plus 9 over 32 minus 27 over 384 plus 81 over 6,144. And of course, if you use your calculator on this, it will come out to be approximately 0.474. Notice the steps. Step 1, plug exponent into formula. Number 2, simplify to fractions. Number 3, we could add up these fractions and divide. I just use a calculator. To avoid all of the long division, etc. All right, let's take a look at another one, remembering these steps. What would be e to the 0.35 power? Well, that would be 1 plus 0.35 plus 0.35 squared over 2 plus 0.35 to the 3rd power over 6 plus 0.35 to the 4th power over 24. We're only going out 5 terms, just as an approximation. If you use a calculator to calculate that, it's 1.419. And that's how we were able to use power series to calculate the value of e to any power. And this can be done, as you can see, could be done longhand if you knew how to, or were willing to do all of the squaring and cubing and dividing longhand. You could calculate what e to the 0.35 power is. Something that we could not do if we didn't have power series.